Oh, my name is Shania, and today I will explain you about the wrong answer of the chemistry exam. So the first question is, when chlorine gas is analyzed in a mass spectrometer, 35Cl plus ion are detected. Which row is correct? From this question, we know that this is a chlorine gas, and this type of question, one us to eliminate the question. So let's start. First, we know this is chlorine, which is chlorine have the atomic number is 17, which is this is the proton of uh, chlorine. So uh, the neutron of chlorine, we know that this is show us 35. So 35 minus the proton, which is 17, so the neutron is 18. From this we can eliminate the option A and option B. And then uh, this question asks about electronic configuration of 35Cl+, which is the total is 16. So 1s2, 2s2, sorry, 2s2, 2p6, 3s2, and 3p6. This is the if they ask not put plus. 3s2 and 3p 3s2 and 3p4. So we can eliminate this one, and the final answer is C. Okay, we move to the next question. The question number 4. The oxide of titanium TiO2 is used as a whitener in toothpaste. It is obtained from the ore iron titanate PeTiO3. What is the change, if any, in the oxidation state of titanium in the reaction PeTiO3 to TiO2? So first let's remake PeTiO3 become TiO2. So we know that Ve is plus 2, so let's make plus 2 plus Ti in here we don't know, so let's just make X, and plus O3 is minus 2, so there's 3 O in here, so 3 times minus 2. It's become Ti, we don't know, so X plus O2. O is minus 2, so 2 times O minus 2. In here we know that let's make plus 2 plus x plus 3 minus 3 times minus 2 equals to 0. So we know that the x in here is 4, and this one x equals to x equals to 4, so it's also 4. In here we know that there is no change, so the answer is D. Okay, next is question number uh, next is question number 8. Question number 8, gas Q decompose slowly at room temperature. Q, the Boltzmann distribution curve for gas Q at room temperature is shown. This change of this catalyst in added to gas Q. So, energy activation is the minimum energy required for a reaction to occur. If the temperature is increased, the number of particles will sufficient energy to react will increase also. A catalyst doesn't increase the kinetic energy of the particle. The average kinetic energy of the particle remains the same. So the answer is B. The number of particles with enough energy to decompose is increased. Goes to the question number 9. When copper is added to a solution of silver ion, the following equilibrium is established. In here, shown the equation. The question is, what is the concentration of silver ion at equilibrium when Cu2 plus is equals to 0.10 molly and minus 3? Okay, so we know that Kc is equals to 1.0 times 10 to the power of 5, and it is given that Cu2 plus is equals to 0.10. So Kc is equals to Cu2 plus, Cu2 plus divided by Ag plus, because the Ag is 2, so square is equals to, so it is given that Kc is 1.0 times 10 to the power of 5 is equals to the Kc, it is given that 0.10, and the Ag, we don't know the Ag plus square. And then so if we want to find the Ag plus square in here, we have to divide it. 0.10 divided by 1.0 times 10 to the power of 5. So the Ag plus is root of 1.0 times 10 to the power of minus 6, which is 1.0 times 10 to the power of minus 3. And the answer is C. Okay, question number 12. Catalytic converter are fitted in the exhaust system of car. Which gas can cause acid rain if it is released into the air, and also the gas can remove from gas exhaust fume by a catalytic converter. It is given that there is carbon dioxide, carbon monoxide, hydrocarbon vapor, and also nitrogen dioxide. CO2 not causing acid rain, so we eliminate this one. And for carbon monoxide, CO can remove catalytic converter but not causing acid rain, so it's also eliminated. The next hydrocarbon vapor. Hydrocarbon is actually oxidized by catalytic converter, but hydrocarbon vapor not causing acid rain, so it's also eliminated. So the answer is D, nitrogen dioxide. Okay, we move to the next question. How many sigma bond and pi bond are in the molecule this molecule? So let's just draw it. Where we should draw it? Okay, here. So the bonding is HC, triple bond with C, bond with CH2, and bond with CH2, bond with CH, double bond C, and CH3. Okay, so in here, there is two sigma bond and two pi bond, and in here, there is 6 sigma bond, and in here there is 2 sigma bond and one pi bond, and in here there is 9 sigma bond. So the answer is 19 sigma bond and 3 pi bond. We move to the next question. The question number 37. The infrared spectrum of compound P is shown. This is the spectrum and it shows this big hill in here. So it shows like in from here to here. It shows there is O that bond with H. Okay. If there is O bond with H, so we should eliminate the option A and option B because it not contain O with OH. And for the option C, propanoic acid, if compound is carbolic acid, there should be a strong peak around 107,700 centimeter minus 1. However, the spectrum does not show the characteristic strong peak around 1,700 centimeter. So the answer is D, propan 2O. So the question number 27, which compound is a product of the hydrolysis of CH3, CH2, CO2, CH2, C2, and H5 using aqueous sodium hydroxide? Remember, if any ester reacted with NaOH, it's called base hydrolysis. So the end of the result will definitely be salt and alcohol. So the answer is A. To the next question, artemisinin is a powerful anti-malarian drug. This is the artemisinin shown here. And the question is how many chiral centers are there in each molecule of artemisinin? Chiral center is main bond with 4 different compounds. So in here, there's no chiral, sorry, there's no in here. There's none here, not in here, and also not in here. And it's also not in here because it's double bond with O. So the chiral is in 1, 2, 3, 4, 5, 6, and 7. So the number of chiral is 7. The next question is question number 22. In which reaction is the organic compound oxidized? So it's given that there is a compound and solvent reagent and the other. Remember, if any organic compound bind with more oxygen or less hydrogen, it is undergoing oxidation. Now, if you have encountered Tollens reagent, its function is to oxidize aldehyde until they produce a beautiful silver mirror in the test tube. So the answer is CH3, CH2, CH2, CHO plus Tollens reagent. The next question, question number 24. The question is which reaction will distinguish between propan 1-ol and propan 2-ol? So propan 1-ol primer, if oxidized, it's become aldehyde, and propan 2-ol secondary, if oxidized, become ketone. After we know to difference, we have to test it with Fehling reagent. So the answer is D, mild oxidation followed by reaction with Fehling reagent. Okay, we move to the next question. Methane and bromine react by free radical substitution. P and Q are involved in a reaction mechanism. P and Q have a characteristic. P and Q are both involved in propagation steps as reactant and both involved in termination steps as reactant. So, in propagation stage, there are two radicals that advance reactant or attackers, namely bromine radical and the methyl radical. Meanwhile, in the termination stage, all the reactants are free radicals that pair up to end the reaction. Here, uh, we can see that bromine radical and CH3 radical come again as a reactant. So the things that uh, like the characteristic is Br and CH3. So we move to the next question. Which compound has the molecular formula of C6H10O? So let's draw it first. I'll draw it here. So C6 is like this. And we'll bond in here. C is double bond, and then it was H in here, H in here, 2H in here, also 2H, also 2H, and this also have 2H. And if plus O, so uh, it gonna be A. So the molecular formula of C6H10O is A. Go to the next question. The question number 14. Sample of gases CH3Cl and Cl2 are mixed together and irradiated with ultraviolet light. Which compound is produced by the termination step in the reaction? So in propagation, reaction between CH3Cl and chlorine radical will produce CH2Cl. But in termination stage, two radical chloromethyl can meet each other and combine, so it becomes CH2Cl, CH2Cl. So the answer is C. The termination step in the reaction is CH2Cl, CH2Cl. Assalamualaikum warahmatullahi wabarakatuh. So to the next is paper 2. Uh, First question is the element of group 17 are called halogen. Complete table 1.1. This is determined that there is three element of group 17, which is chlorine, bromine, and iodine. We have to determine the color of that element at 293 Kelvin. So in 293 Kelvin, the color of chlorine is pale green, and the color of bromine is red or brown, red to brown. And the color of iodine at 293 Kelvin is dark purple. Okay, so the question of the sub-question A is done. We move to the B. State the trend in volatility of the halogen, chlorine, bromine, and iodine. Explain your answer. So when the molecule is getting larger, so the intermolecular force or van der Waals force is become stronger and need more energy to break. So the volatility T decrease down the group. Okay, and we move to the C. Iodine is made by reacting bromine with sodium iodide. Construct an ionic equation for the reaction of bromine with sodium iodide. So in this question, we have to make the equation, which is Br2 plus 2I minus, it's become 2Br minus plus I2. We have to check is it balanced or no. Br is 2, iodine is 2, so it's already balanced, so it's correct. We move to the next question. State the role of bromine in the reaction. Explain your answer. So, the role of bromine in here is bromine is the oxidizing agent. Oxidizing agent. Because in here bromine gains electron and it's reduced, so the bromine is an oxidizing agent. We move to the next question. Concentrated sulfuric acid is added to separate samples containing equal amount of NaCl, NaBr, and iodine. All three samples initially react to produce the hydrogen halide. Write an equation to describe the acid-base reaction that occurs when concentrated sulfuric acid reacts with NaBr. So in here we also have to make the equation. So NaBr reacted with sulfuric acid H2SO4. It's become NaHSO4 plus HBr. This is the question. The next question. Deduce which sodium halide, NaCl, NaBr, or Ni produce the largest percentage yield of hydrogen halide when concentrated sulfuric acid is added. Explain your answer by considering the relative reactivity of the halide ions as reducing agent. So in here the question asks us about identify of sodium halide and also explanation. So the sodium halide in here is NaCl, and chlorine ion or Cl- are the weakest reducing agent, so they cannot reduce concentrated sulfuric acid. So HCl gas produced does not react it further and give the highest yield. We move to the next question. The next question is, the period tree elements show trends in physical and chemical properties across the period. A. Figure 2.1 show the variation in atomic and ionic radius of the period tree element Na2Cl. The ionic radius of Si is not shown. So this is the figure 2.1. The black one is atomic radius and the white one is ionic radius. The question: explain the trend shown in atomic radius of the period tree element Na2Cl. So going across the period, the number of proton increases. When the proton is increased, the nuclear charge of course getting higher. This stronger positive charge pull the outer electron closer to the nucleus. So the answer is the atomic radius increase from Na to Cl. The atomic radius is increased. Sorry. The atomic radius is decreased from Na to Cl. Okay, we move to the next question. Group 2 metals form alkaline solution in water. Give the equation for the reaction of calcium oxide with water. So, calcium oxide is CaO plus 2H2. Plus H2O. It's become CaOH2. Because it said that the H is 2, so we add 2 in the front of H2O. The next question, identify the ion that causes an aqueous solution to be alkaline. The ion that causes an aqueous solution to be alkaline is OH minus or hydroxide ion. Next question. The table shown the melting point of some group 2 metal oxide. Explain the trend in melting point of the oxide down group 2. In this table, we know they given the data that the melting point of MgO, CHO, SRO, and also BHO. So the melting point decrease down the group. Melting point decrease down the group. Why? As it goes down, the ionic radius of the metal cation increase, which weaken the attraction between the positive metal and negative ion or O2 minus. This situation decreases the lattice energy. That's why the melting point decreases down the group. Next question. Oxygen reacts readily with some metals, but each group 2 metal requires strong heating to start the reaction with oxygen. Suggest why strong heating is required to start this reaction. Why strong heating is required to start this reaction is because this reaction has a high activation energy. Reaction has a high reaction has a high activation energy, so it is need to break the strong bond in the reactant initially. Beryllium oxide reacts. The next question: beryllium oxide reaction with hydrochloric acid to form molecules of BeCl2. Deduce the bond angle in BeCl2. So Be bonding with Cl2. Cl. It is a linear shape because there is a two bonding pair here, and no lone pair. So the angle is 180 degrees. Next question. Magnesium oxide reacts reversibly with chlorine according to the following equation. This is the equation, and under sustained condition, a dynamic equilibrium is established. State two features of reaction that is in dynamic equilibrium. Dynamic equilibrium is when the rate of forward reaction is equals to reverse reaction. So we can write in here forward reaction is equals to the reverse reaction. And the second situation is when the concentration of the reactant or product is constant. Concentration of reactant and products remain constant. Okay, we move to the next question. The equilibrium constant Kp is given by the following expression. It is given the formula in here, and they also give us that at 1.00 times 10 to the power of 5 Pa. So this is the total pressure, and from this we have to look for the pressure of O2 and also the pressure of Cl2. So O2, Cl2 first. Cl2 is 0.6 mole and O2 is 0.7 mole. And then the total of the mole of the gas is 1.3 mole. Total pressure, they also given us that the total pressure is 1 times 10 to the power of 5. So PCl2 is Cl2 is 0.6 per total, which is 1.3 times the total pressure 1.00 times 10 to the power of 5, which is the 5.38 times 10 to the power of 4. And for the PO2, we know that it is 0.7 per the total is 1.3 times the total pressure 1.00 times 10 to the power of 5, which is 4. The next question, the equilibrium constant Kp is given by following expression. This is the formula we get, and also at 1.00 times 10 to the power of 5 Pa. This is the total pressure. So we have to know that what is the pressure of O2 and pressure of Cl2. Cl2 is 0.6 mole and O2 is 0.7 mole. The total of the mole is 0.6 times plus 0.7 is 1.3 mole. The total pressure is given that 1.00 times 10 to the power of 5. So PO2 is 0.7 per total is 1.3 times the total pressure 1.00 times 10 to the power of 5. The answer is 5.38 times 10 to the power of 4. We can use calculator in here. And also PCl2. PCl2 is 0.6 per 1 per 3 times 1.00 times 10 to the power of 5, which is the total is 4.62 times 10 to the power of 4. We already get the PO2 and PCl2, so we just need to substitute to here to the formula. So Kp is equals to PO2. PO2 in here is 5.38. 5.38 times 10 to the power of 4 per P square Cl2. So we have to substitute this amount but square, so 4.62 times 10 to the power of 4 to the power of 2. When we use calculator, we get the result that is 2.52 times 10 to the power of minus 5. And the unit is Pa minus 1. So just put in here 2.52 times 10 to the power of minus 5 The unit is Pa minus 1. This is the answer. Okay, we move to the next question. Magnesium peroxide MgO2 is made in the following reaction. This is the equation, and also it's given that delta H is equals to minus 96 kilojoule per mole. And then the first question is the peroxide ion is O2 2 minus. Deduce the average oxidation number of oxygen in the peroxide ion. The average oxidation number is minus 1. The next question, define the term enthalpy change of formation. Enthalpy change is when one mole of compound, is formed from its element in their standard state. So this is what the definition of enthalpy change of formation. When one mole of compound is formed from its element in their standard state. The next question, use the data given to calculate the enthalpy change of formation of MgO2. This is the data given that there is the delta H of the equation, which is minus 96 kilojoule per mole, and also enthalpy change formation, this, and this. So we have to look for enthalpy change of formation of MgO2. So the formula is delta H reaction is equals to delta enthalpy change of formation of the products minus enthalpy change of formation of the reactant. So we know that delta H reaction is minus 96 kilojoule per mole, and the product is it shows that the product is MgOs, MgO in solid and H2O2 in liquid. So MgO is the things that we have to looking for, but H2O2 is H2O I mean, it's defined in here is minus 286. So we have to make it like this, delta HF of MgO2 plus minus 286. Minus the reactant is minus 600 of 2 plus minus 188. So it's become like this. Minus 96 is equals to delta H, enthalpy change of formation of the MgO2 plus 504. So the enthalpy change formation of MgO2 is equals to minus 96 minus 504 is equals to minus 600 kilojoule per mole. So the answer is minus 600. Next question, question number 3. Hydrocarbon molecule contain covalent bond. Define covalent bond. Covalent bond is attraction between nuclei of two atoms and shared pair of electrons. This is what defined as a covalent bond, attraction between nuclei of two atoms and a shared pair of electrons. The next question, a C double bond in an alkene is made from a sigma bond and a P bond. Identify the hybridization of carbon atoms in a C double bond. It is sp2, sp2, sp2. Draw label diagram to show in terms of orbital overlap from the sigma bond and pi bond are made in C double bond. And for the P bond, it is like this. And this is the P or orbitals. And the next, in electrophilic reaction involving alkene, the P bond of C double bond is broken. Complete figure 5.1 to show the mechanism for the electrophilic addition of hydrogen bromine to 2-methylpropane to produce the major organic products. Include charge, dipoles, lone pair of electron, and curly arrows as appropriate. Okay, so we have to add that detail in here. So the C double bond is broke down with this. This is adding with this plus H and bond with Br minus. Okay, and the next is it becomes H3C bond with C, bond with C, bond with H. And then this one bond with H, bond with H, and this one bond with CH3, and this is plus, and the Br minus get into here, and it's become H3C bond with C, bond with C, bond with H. H is, it's also H, CH3, and it's Br. This is the final answer. Okay, so the next question, complete the dot cross diagram showing outer electron only to show the bonding in methanoic acid HCO2H. So, and here we also have to draw, right? Because O is half constant 6, so like this. Sorry, so bad. Four more, so we put it out. Okay, And also there's a bonding here. There's a bonding here. And the O has 6, so it have 2 more in here. And also there's a bonding here. So this is how the methanoic acid bonding. Next question, hydrocarbon Y react with H2 in gas. Figure 3.3 show the distribution of energy of H2 at temperature T. Area A represent the number of molecules with energy greater than or equal to the activation energy EA at temperature T. The question 1 annotate figure 3.3 to show the effect of adding nickel to Y and H2 at temperature T. So we have to add the effect. I will add it in here. Sorry. Okay, so this is the EA, activation energy in here. The next is area B, not labeled in figure 3.3, represent the number of molecules with energy greater than or equal to activation energy when nickel is added at temperature T. State the difference, if any, between areas A and B. Explain the significance of your answer on the rate of hydrogenation of Y. Give your answer in terms of collision. So it want us to state the difference and also in terms of collision. So if state the difference, just state like increase in the rate of the rate of effective or successful collision. Successful collision. So this is the answer.